Hello friends, welcome back to our YouTube channel. If you like this video, please like, share and subscribe. I'll share our videos commanded by our experts, so let's begin.
Showcase. If you like, please like, share and subscribe. So let's begin our today's topic. Let's begin.
On May 19th and 20th, 2026, Google I/O returns to the Shoreline Amphitheater in Mountain View, detailing its engineering roadmap for the global developer community. The 10 a.m. main keynote is structured around consumer hardware and broad software functionality. While these announcements reveal the product landscape, the infrastructure-level updates essential for systems architects are discussed in a separate afternoon session. This timeline illustrates the actual target for engineers, the 1:30 p.m. PT developer keynote. This is where Google will deploy critical API updates and new engineering tools. We are bypassing the morning consumer announcements to focus exclusively on the technical schedule. The core theme driving the 2026 technical sessions is agentic coding. This concept moves away from basic autocomplete utilities in favor of autonomous, multi-step code execution workflows. Google is enabling this by integrating deep structural AI directly into Android 17, alongside a brand new professional framework called Google Antigravity. To prepare for the May 19th rollout, engineers need to understand exactly how these disparate announcements map together into an entirely new, unified developer tech stack. This diagram maps Google's new ecosystem from the bottom up, establishing the architectural foundation. At the base layer, we find the Gemini Evolution updates operating alongside AI Studio. The primary architectural update to the Gemini model is a reduction in latency, specifically optimized for continuous inference tasks. When an agent evaluates sequential steps and iterates on its own output, low-latency continuous inference is the mandatory compute baseline required to keep those loops operational. To manage this, Google AI Studio is expanding into the native environment where developers will tune, test, and evaluate these continuous inference models. Directly above that foundation sits the middleware layer, Google Antigravity. Antigravity is a dedicated professional framework built explicitly to host and manage autonomous coding agents. This represents a major departure from the traditional developer workflow, specifically moving away from manually writing rote boilerplate code. Instead, engineers will use antigravity to define strict parameters, set constraints, and orchestrate high-level tasks for the agent to execute. The framework secures the process by allowing engineers to tightly manage API boundaries, isolating sensitive systems while the agent generates the internal logic. During the 1:30 p.m. developer keynote, engineers should look for the initial SDKs and integration paths specific to this framework. In this architecture, Gemini provides the raw cognitive horsepower, while antigravity acts as the transmission, converting that reasoning into safe, executable software workflows. Moving up to the deployment layer, we find Android 17. The official schedule documents deep structural AI advancements within this operating system update. This diagram compares the outgoing standard with the new architecture. On the left, traditional apps rely on external API calls to access cloud AI. On the right, Android 17 embeds AI nodes directly into the OS framework and hardware abstraction layers. By utilizing this embedded design, the system can bypass the application layer entirely. Developers now have direct API hooks into native, system-wide context. Applications can read from and write to native device memory, utilizing OS-level APIs, which removes the need to construct custom databases just to store AI context. Task execution is parsed and handled natively by the operating system, rather than routing through third-party models. Because the intelligence is baked directly into Android 17, developers no longer need to bundle heavy, redundant model weights within their individual application payloads. This embedded methodology extends beyond mobile devices. Dedicated technical sessions show this architecture deploying across Chrome, Cloud, Wear OS, and Flutter. All 4 deployment environments route back through antigravity and down into the core model. The Gemini architecture serves as the shared, unifying compute layer across these previously fragmented platforms. Upcoming sessions will detail exactly how Flutter integrates with agentic code generation to streamline cross-platform builds. Updates to Chrome will focus on optimizing the browser's runtime environment to process structural AI tasks locally. Google Cloud updates will detail the infrastructure required to host and scale these agentic frameworks in production. a unified stack routing through a central cognitive engine forces architects to move away from siloed app features in favor of integrated cross-platform architecture. This completed diagram illustrates the new engineering standard. Data flows from the Gemini model through the anti-gravity middleware and out to the ecosystem deployment nodes. As these integrations become native, the reliance on application layer AI wrappers is effectively ending, replaced by structurally integrated agentic system architecture. The division of labor is exact. Gemini executes continuous inference, anti-gravity orchestrates the autonomous agents, and systems like Android 17 handle local execution. For technical leads, mastering the new Android 17 SDKs and anti-gravity integrations is the mandatory baseline for future development. With a massive global audience preparing for this release, securing the right technical insights early is critical for staying ahead. Navigate to the official Google I/O website. Register for the digital event to establish a verified developer profile. Use the site's scheduling tool to filter specifically for the 1:30 p.m. PT developer keynote. Locate the dedicated technical sessions covering anti-gravity and Android 17 and save them directly to your calendar. The tools to build the next generation of software go live on May 19th. Preparation starts today. Google I/O 2026 arrives at a point where the complexity of software architecture is beginning to exceed the capacity for manual, line-by-line maintenance. The event is officially scheduled for Tuesday, May 19th and Wednesday, May 20, returning to the Shoreline Amphitheater in Mountain View. While the event is broadcast to a global audience, the technical roadmap is found by looking at the specific distribution of the May 19th sessions. The main keynote at 10 a.m. PT focuses on consumer products. However, the developer keynote at 1:30 p.m. PT covers the engineering tools, including new APIs and SDKs. This sequence suggests that the technical updates following the developer keynote will determine the specific methods used to build software moving forward. Current development relies on AI for code suggestions and autocomplete. Agentic coding moves that responsibility to the AI, allowing the model to manage and execute the architecture itself. This transition requires a full realignment of the existing developer ecosystem, from the kernel level to the application framework. The I/O 2026 schedule organizes these updates into a 4-layer stack designed to support autonomous execution. This stack consists of the foundation models, the operating system, developer frameworks, and the deployment ecosystem. Mapping these 4 layers provides a technical view of how developer workflows are being automated. At the base of this stack, the schedule lists sessions on Gemini evolution. These sessions detail architectural changes to the Gemini model itself, rather than just simple performance tuning. Standard foundation models typically function through fixed API prompt routing, which limits their ability to handle complex, multi-step engineering logic. To address this, Google is expanding the capabilities within Google AI Studio. These expansions allow engineers to directly modify model weights and contexts, providing more precise control over the model's behavior. This level of manipulation at the base layer is required to support the autonomous agents running in the upper layers of the stack. As a result, the Gemini model is being positioned as a malleable foundation for custom engineering. The second layer of the stack focuses on the operating system, specifically the updates arriving with Android 17. The official schedule highlights deep structural AI advancements within this version of the OS. This represents a shift from running AI as an application to integrating it into the core system services. By embedding AI at this level, Android 17 can manage memory, compute, and battery resources dynamically based on the predicted needs of the running software. For developers, this changes how APIs interact with hardware, as the system begins to anticipate requests rather than waiting for manual calls. This integration effectively turns the operating system into a routing agent for the rest of the stack. Android 17 provides the low-latency environment necessary for agentic code to interact with physical hardware. The third layer introduces the Google Antigravity Framework. Traditional programming follows a linear cycle of writing code, compiling, and testing. This linear process creates bottlenecks when developers try to integrate and scale complex machine learning features. Antigravity utilizes an agentic loop. Instead of a linear path, autonomous nodes write, test, and self-correct in a continuous cycle. The framework monitors these loops, where Node A drafts logic while Node B simultaneously tests it for security compliance. This allows the framework to orchestrate the software architecture itself, rather than simply providing a space to write text. Post-2026, the ability to manage these execution loops will be a defining skill for senior engineers. Antigravity transitions the developer role from writing syntax to managing entire systems. The final layer of the stack is the deployment ecosystem, which is addressed in various technical sessions on May 19th and 20. The architecture of the lower layers is only effective when it integrates with the platforms where code is actually executed. Sessions on Chrome and Cloud demonstrate how agentic code handles web rendering and remote execution at scale. Similarly, updates to Flutter and Wear OS show how cross-platform frameworks are being updated to work with OS-level AI. These sessions are where the automation managed by Antigravity is applied to real-world applications. These platforms represent the final delivery mechanism for the logic generated throughout the stack. Viewed as a single unit, the I/O 2026 schedule describes a unified machine for software production. This stack provides the framework for a development cycle where AI is a native component of the engineering process. As these automated systems take over the generation of granular syntax, the developer's role changes. The focus shifts to the design and management of the autonomous workflows that Antigravity and Android 17 support. Navigating this new architecture is necessary for any engineer looking to work within the updated Google ecosystem. Adapting to these changes begins with registering for the event's digital sessions. The official Google I/O website is the starting point for setting up a developer profile. From there, you can save the specific sessions for Antigravity and Android 17 to your calendar to track the technical breakdowns as they are released. These tools and sessions become available on May 19th, providing the technical basis for the next stage of automated engineering.